Hello people, this is Krishna Mitro. Today I am going to discuss about the architecture of microprocessor 8085. So as we know that microprocessor is became more popular during this era as because of almost every electronics and electrical devices uses microprocessor. So microprocessor first came into picture 40 years ago, and then after lots of development have been made on microprocessor, but the basic structure became the same. That's why we study about the 8085 microprocessor, which is the first commercially successful microprocessor. So what does microprocessor do? The basic function of microprocessor is to execute a program, and a program consists of so many instructions. So microprocessor basically execute instructions one by one so that it can execute the whole program. So let me take an example that if we want to open the WhatsApp in our mobile, what we do first, we just open our mobile and then click on the WhatsApp icon. So the icon which we are seeing in our mobile is nothing but the address location of the memory where the whole program of WhatsApp is stored. So WhatsApp is nothing but a program. So when we want to open WhatsApp, we just tap in the icon. So that and the memory location of WhatsApp will came into the program counter of the microprocessor. As if we see the whole structure of microprocessor, internal structure of microprocessor, we will see that there are so many blocks are there, as we can see in the diagram, and there are so many registers are there, and there are two types of registers. One is a general purpose register, another one is special purpose register. So the general purpose register are those which are accessible by the programmer, and the special purpose register are not accessible by the programmer. Microprocessor is using the special purpose register to execute a program, and the general purpose register are used by the programmer. The accumulator is a general purpose register. B, C, D, E, H and L are the general purpose register. There are 7 general purpose register in the microprocessor architecture. So first the address of that program will came into the program counter, that means PC. You can see in the diagram. Then PC will send that address location via address bus to the memory, and then memory will send the first instruction of that program through data bus to the instruction register. You can see the flow of the operation. First we tap the WhatsApp icon, so the memory location of WhatsApp will come to PC, program counter. Then program counter will send a signal to the memory via address bus. We can see the address bus in the diagram. Via this address bus, the program counter will send a signal to memory that we need to fetch. Fetch means it need to access that whole content of that memory location. So program counter will send a signal to memory via address bus. Then memory will send the content of the program via data bus to the instruction register, and the instruction register will send that instruction to the instruction decoder. Instruction decoder will decode that instruction as the microprocessor. As we programmer write the program in assembly language, but microprocessor does not know about the assembly language. It only know the zeros and ones, so it need to decode that assembly language to machine language. So that's why the instruction, after fetching the instruction register will send that instruction to instruction decoder. Then instruction decoder will decode that instruction and send it to the timing and control unit. Timing and control unit will send a read signal to the memory. Okay, so this is how it will fetch all the instruction from the memory. So this is how a microprocessor fetch all the instruction from the memory. So this is the cycle. You can see again. First, when we tap any program icon on our mobile, the address of that memory of the memory location where the program is being is stored will come to PC. Then PC will send a signal to the memory via address bus. Then from memory, the instruction will come to the instruction register via data bus. Then the instruction will go to the instruction decoder to decode that instruction, so that microprocessor can understand what's going on or what task it need to perform. Then it will send to the timing and control unit, and timing and control unit will send a read signal to the memory to fetch all the instructions. So this is how one instruction cycle will complete, and we can this is how the block in the diagram we can see the instruction register, instruction decoder, timing and control unit, program counter are working step by step. Okay, now after fetching the instruction, if there is a addition program, say suppose we need to add some data, and as we know that first data will be in accumulator and second data will be any one of the general purpose register like B, C, D, E, N, H and L. So say suppose one data is in B register and another data is A register, and we need to add these two data. So timing and control unit will send a signal to the accumulator and B register and as well as the ALU, and it will say to these devices that add the data which is available in accumulator and B register. It will send this signal to the accumulator, ALU. Then ALU will fetch that data which it need to be added. So the data which is available in B register will come to the temporary register via marks, and then from temporary register one apparent will come to the ALU, and one apparent from accumulator will come to the ALU. Okay, then then ALU will add that data and send it back to accumulator again. Okay, and there is another block we can see flag connected to the ALU. So the purpose of flag is to show the nature of the output of ALU. The nature of output means after addition the data, whether it is 0, whether it is positive, whether it is negative, it will be shown in the flag register. And one thing is need to remember is that flag register can only show the current available output. it will not show the previous output data. Okay, it will only show the condition of present input present output data. Okay, and then it will store in accumulator again. To understand the working of accumulator, we can take an example. Say suppose we need to add 3 data, so we have to write the program like add b. That means the data which is available in b need to add it with the accumulator. Okay, we cannot mention in microprocessor accumulator. We cannot mention the register accumulator. It is inbuilt that the first data will be in accumulator. Whatever operation is being performed, the first data will be in accumulator and the second data will be either in B register or C register, D, E, H and L. It can be anywhere, but the first data will be in accumulator, and the output of the ALU will be also stored in accumulator. So if we want to add 3 data, that means suppose we have write a program that add add B, then add C, then add D. So what will happen? Accumulator will take the data from accumulator and add it with the B register, the value of the B register, and it will send to the accumulator. Then again ALU will take the data from accumulator and from register C it will add, and then it will also again store in accumulator, and then at last it will take the data of D and it will add with the value of accumulator, and then again it will store the value with the in the accumulator. So this is how microprocessor works. So this is how we can understand that what is program counter. So program counter will first save the memory address from where we need to execute a program. So it will store the memory location only. Program counter will only save the memory location. Instruction register will only collect that instruction from the memory which need to be executed. Instruction decoder will decode that instruction simultaneously, and it will send to the timing and control unit for the rest of work. Timing and control unit will send the signal to the different part of the microprocessor to perform its operation. So the timing and control unit is like the brain of the microprocessor. It will instruct it will instruct all the parts of microprocessor that what operation need to perform, whether it will write something, it will read something, it will whether accumulator can be activated, whether flag the data which is stored in flag is positive or negative. All these things is controlled by the timing and control unit. Then the accumulator, the purpose of accumulator is to hold the first apparent, and it will also and then after it will hold the result of ALU. Temporary register will temporarily store the value of register B, C, D, E, H and L and it is the second operand of ALU. Flag register will show the characteristics of the output of ALU, whether the output of ALU is positive or negative, whether there is any carry, everything will show in flag. So these are the main parts. There are other parts also like increment and decrement, as you can see in the register part. The purpose of increment and decrement is when the microprocessor will fetch the first instruction, it will it will execute, it need to be executed the second instruction also. So when the first instruction will came to the instruction decoder, program counter need to be incremented so that it can read the second line of the program. So this thing is being performed by the instruction increment or decrement register. Okay, now stack pointer is a very stack is a very important thing. It's only store the memory location of the last data. As we know the stack, what is stack, it's only hold the address of the memory location of the last data. Okay, so this is the main working of 8085 microprocessor. Thank you.